In this video, we're going to cover section 9.6 on the hydrohalogenation of alkynes. Similar to what we observed for alkenes, Markovnikov addition is observed when alkynes react with hydrogen halides. So as you can see in this example, we have a terminal alkyne reacting with a hydrogen halide. We observe the formation of a bromoalkene, and the halogen will be placed at the more highly substituted position of that original terminal alkyne, which is only going to be this side of the alkyne. If we use excess hydrogen halide, so a minimum of a 2-to-1 ratio, we'll observe the formation of a geminal dihalide. So we'll have two halogens adding to the more highly substituted carbon, that is, the carbon of the alkyne that has an alkyl group attached to it. Now, the mechanism for the hydrohalogenation of alkynes initially was thought to be similar to that for alkenes. However, if an alkyne undergoes the same mechanistic steps, that is, starting with a proton transfer from the hydrogen halide, we would expect the formation of a vanilla carbocation. Now, the problem with this proposal is that vanilla carbocations are very unstable, and so it's unlikely that they form. And so as a result, this mechanism is considered not to be the proposed mechanism for hydrohalogenation of alkynes. Further study into the mechanism for hydrohalogenation of alkynes suggests that the transition state for this reaction goes via a termolecular process. That is, there are three molecules interacting at the transition state. So as you can see in this example, the terminal alkyne is interacting with two molecules of the hydrogen halide. One carbon, the carbon that is more highly substituted, is interacting with the incoming halogen, and the other carbon of the alkyne, which is unsubstituted, is going to be eventually protonated or take on that hydrogen from a second equivalent of the hydrogen halide. So this termolecular process is very uncommon, but is strongly supported from kinetic studies. Similar to what we saw for hydrohalogenation of alkenes, we can also regioselectively hydrohalogenate an alkyne. So if we add an alkyl peroxide in the presence of our hydrogen halide, we will observe anti-Markovnikov addition. And as you can see in this example, again, the terminal alkyne reacting with the hydrogen halide in the presence of the alkyl peroxide. We saw with alkenes, this was a radical reaction. It's believed that this is also a radical reaction in the presence of an alkyne. What we do observe is a mixture of isomers. We obtain both the E and Z, or cis and trans isomers in this example, for the final bromoalkene. So from the reactions that we've discussed so far, we now can show that we can interconvert between alkynes and dihalides. So we just saw that we could take an alkyne and with hydrohalogenation in the presence of excess hydrogen halide, we can prepare a dihalide, a geminal dihalide. We can take that same dihalide and in the presence of excess sodium amide and liquid ammonia, followed by a water quench, we can prepare the terminal alkyne. And so these sets of reagents, if you will, can be used to transform from alkyne to dihalide and dihalide to alkyne. So they become very synthetically useful if we start with a dihalide and wish to prepare the alkyne, or vice versa. So if you have any questions about hydrohalogenation of alkynes, please send me an email and we can discuss it further. Thank you.